In the early hours of November 9th, 2025, a wave of confusion spread through observatories across the globe. From Chile to the Canary Islands, every major telescope logging data from 3i Atlas showed the same abrupt distortion, a deviation so clean, so simultaneous, that coincidence was ruled out within minutes. For several seconds, the object emitted a spectrum of light that shouldn't exist, a wavelength falling neatly between known atomic transitions. Instruments recalibrated automatically, but the anomaly persisted, steady and deliberate, before vanishing as suddenly as it appeared. Researchers initially suspected solar interference or instrument synchronization failure, but internal logs told a different story. Each observatory's timestamp matched perfectly, down to the microsecond, despite operating on independent time bases. In the quiet after the event, the question wasn't whether something had happened. It was how something hundreds of millions of kilometers away could coordinate that precisely. The response was immediate. Data archives were frozen, cross-check systems engaged, and internal channels lit up with messages marked Priority 1. The scientific community had seen 3i Atlas behave strangely before. Its irregular trajectory, its inexplicable emissions, its pulse-like cycles, but nothing on this scale. Nothing that affected every sensor at once. In the hours following the anomaly, the first question scientists asked was simple. What exactly did we see? The data pointed to a narrow spectral band, centered between ultraviolet and visible light, that doesn't correspond to any known atomic emission. No element, compound, or molecular transition on record emits in that range with the precision and intensity recorded that night. Yet, every observatory that had 3i Atlas in view registered the same pattern, a thin, stable line that held for just under 4 seconds, long enough for calibration systems to lock onto it, too brief to capture its full physical nature. Spectroscopy teams at Mauna Kea and the European Southern Observatory immediately pulled their logs. The light wasn't simply reflected sunlight or scattered particles, its wavelength carried the distinct fingerprint of an emitter, not a reflector, the difference between a mirror and a light bulb. That realization changed everything. It meant the object, already known for its irregular energy bursts, had generated a new emission entirely on its own. The absence of accompanying heat spikes made the event even stranger. Normally, high-energy emissions produce corresponding infrared signatures, but thermal data from JWST showed the object cooling during the flash, not heating. At NASA's Goddard Space Flight Center, analysts checked for cosmic ray contamination. High-energy particles striking sensors can mimic false readings, but the consistency across instruments ruled it out. A cosmic ray event would scatter, not synchronize. The synchronization was absolute. Observatories separated by continents and oceans, operating under different weather conditions and sky orientations, all recorded the same spike at the same universal moment. The probability of that alignment occurring naturally is almost non-existent. What makes this light so peculiar isn't only its existence, but its structure. When decomposed, the signal reveals fine oscillations, minute modulations riding within the spectral band itself. These sub-patterns repeat at exact harmonic intervals, a signature of controlled modulation rather than random emission. It's as if the light carried an underlying rhythm, a microscopic order hidden beneath apparent simplicity. For some analysts, that rhythm suggested interference between multiple coherent sources, as though 3i Atlas contained internal mechanisms operating in synchronization. By mid-morning, discussions had shifted from "what is this?" to "what could produce it?" One hypothesis proposed the presence of exotic plasma interactions, magnetic reconnection events occurring within metallic vapor fields surrounding the object, but such events produce chaotic emissions, not harmonic order. Others suggested quantum coherence effects, similar to those seen in Bose-Einstein condensates, but at astronomical scales that physics currently deems impossible. Then came the energy calculations. Using the emission's intensity and the object's estimated distance, energy output was computed at roughly 1/3 that of a standard cometary outburst. Powerful, but contained. The problem wasn't magnitude, it was precision. The wavelength deviation remained steady to within 1 part in a billion throughout the event, an engineering-level stability that no known natural process maintains. Reports began cross-referencing with data from past weeks. something subtle had been building. Minor spectral irregularities had been noted since late October, faint, easily dismissed anomalies now reinterpreted as precursors. When charted together, those prior disturbances form a rising curve of coherence, as though 3i Atlas had been fine-tuning this emission, adjusting toward a specific output over time. The European Space Agency's remote team labelled the dataset L1, standing for Light 1, to distinguish it from prior radiation bursts. They noticed something else. The emission coincided with a local dip in solar wind intensity, almost like the object timed its release for maximum clarity, avoiding background interference. Whether coincidence or coordination, the effect was undeniable, the cleanest reading ever captured from 3i Atlas. Across research networks, debates turned heated. Some argued for a novel physical phase, an unclassified interaction between ionized metals and interplanetary magnetic fields. Others hesitated, unwilling to dismiss the possibility of artificial modulation. Not intelligent in the human sense, perhaps, but structured, purposeful. That distinction matters. A process can be structured without being conscious, but structure demands rules. Something governed the emission's behaviour, something beyond chaos. In Cambridge, Dr. Sarah Chen's team ran Fourier analyses on the lightwave pattern. The result produced a near-perfect harmonic ratio of 3 to 2 to 1, a resonance uncommon even in engineered systems. Her published internal note described it as a coherent triad within noise, statistically deliberate. For many, that phrasing became the centre of the controversy. If deliberate, then by what? Yet amid speculation, one fact stood untouched. Every observatory confirmed the same impossible light. A beam that emerged from nothing, defied known emission laws, and vanished before any secondary instrument could triangulate its source. By sunrise on November 9th, the night's confusion had evolved into methodical disbelief. The world's observatories, from NASA's deep space monitoring centres to small private telescopes in rural Europe, began comparing timestamps. Each team expected small discrepancies, the kind caused by differences in equipment, location, or network latency. Instead, they found something that should have been impossible. Every record of the emission, down to the millisecond, matched. For those accustomed to the natural imprecision of astronomy, this was more alarming than the light itself. Even synchronized atomic clocks drift slightly due to signal routing, time dilation, or GPS calibration. But here, every observatory's internal time log, including systems entirely offline and air-gapped from the global network, showed identical timing. That level of alignment cannot occur spontaneously. At the National Astronomical Observatory of Japan, an independent review team performed a time correlation check using the original raw packets. Their conclusion was unambiguous. The onset of the emission struck all detectors at exactly 3:41:27.092 UTC. The difference between the fastest and slowest systems was less than 1 microsecond, a precision so perfect it crossed into the domain of deliberate synchronization. In most astrophysical events, even signals travelling at light speed appear staggered when recorded across different observatories due to atmospheric interference and geographical distance. Here, no such delay existed. The implication was either a calibration artifact across all instruments simultaneously, statistically absurd, or a burst of radiation pre-adjusted to compensate for light travel differences. In other words, the emission behaved as if it knew where every observer was located. Scientists at Caltech's Data Synchronization Lab initially suspected a systemic glitch in the global atomic time signal, a disruption that could have forced uniform timestamps across all observatories. But when they compared logs from gravitational wave detectors, which operate on independent timing networks, they found the same synchronization. Even instruments that weren't observing 3i Atlas directly had logged a brief, inexplicable resonance in their background calibration lasers at that precise instant. The findings raised a deeply uncomfortable question. Could an astronomical object adjust its output to account for light travel delay? To do so, it would need to know its exact distance from each observer, something that requires knowledge of position, speed, and orientation relative to Earth's rotation. That's computation, not coincidence. The more data scientists analysed, the stranger the picture became. Satellites operating in high orbit, including SOHO and STEOA, recorded the event roughly 8 minutes before ground-based stations did, exactly the time it takes for light to travel from the Sun's vicinity to Earth. Yet their local timestamps still matched ground-based data perfectly when converted to universal time. That means both data streams, space and ground, were aligned as if orchestrated by a single clock. Researchers began referring to the effect as the synchronization anomaly. In internal communications, it was abbreviated SA1, the first of its kind. What made it so unsettling was not just the precision, but its selective nature. Only systems pointed at 3i Atlas experienced perfect synchronization. Instruments focused elsewhere, including those monitoring nearby solar phenomena, showed normal time variations. The anomaly forced teams to confront an uncomfortable hypothesis that 3i Atlas wasn't merely reflecting or emitting energy, but modulating it in direct relation to observation. In physics, such a concept resembles quantum entanglement or observer-dependent collapse, yet here it occurred across macroscopic distances. No known process allows for this kind of coherence at an astronomical scale. To eliminate human error, several observatories repeated the experiment under controlled conditions the following night. They directed their spectrographs to regions adjacent to 3i Atlas, recording timestamps of standard stellar emissions. The results were normal. When they returned, focused to the object itself, synchronization reappeared. The correlation was absolute. Observe 3i Atlas, and the clocks lock. Observe elsewhere, and they drift normally. This pattern drew the attention of data integrity specialists at CERN, who were accustomed to identifying systemic coincidences. They ran the time data through their collider synchronization algorithms. The result was consistent with what physicists call phase alignment, the simultaneous resonance of multiple oscillating systems without direct connection. Such a state can occur spontaneously in small quantum ensembles, but across planetary distances it requires an external coordinating field. That field, if it exists, is invisible. No radio frequency, no gravitational wave, no neutrino flux showed corresponding variation. The only detectable signature was optical, the same wavelength as the mysterious emission, which means the light itself might have carried timing information embedded within its modulation. If so, then 3i Atlas didn't just emit energy, it transmitted structure. The emission wasn't a flash of light in the conventional sense, it was a packet, a perfectly timed pulse that unified detectors worldwide for a few seconds before fading back into normal noise. At the European Space Agency, engineers began referring to this as the clock event. A private memo circulated later that morning summarized it bluntly. Whatever this is, it isn't behaving like debris or cometary material. It's operating with awareness of observation. Across academic channels, the tone shifted from fascination to quiet unease. For the first time, scientists were forced to consider the possibility that 3i Atlas might be responding, not randomly, but relationally, to being watched. As the world's observatories recalibrated from the synchronization event, attention shifted to the faint rhythmic fluctuations reappearing within 3i Atlas's light curve. At first, the oscillations seemed like residual interference, the kind often produced by atmospheric turbulence or electronic noise after data realignment. But within minutes, that explanation collapsed. The rhythm was too clean, too deliberate, and too globally consistent. This wasn't the first time 3i Atlas had pulsed. Weeks earlier, scientists had recorded a faint 27-minute cycle in its brightness, a periodic modulation so regular it inspired comparisons to pulsars. But pulsars rotate, and their emissions are electromagnetic, not optical. 3i Atlas had no known spin period and emitted no measurable radio or X-ray output. The pulse back then had faded, leaving researchers divided between theories of thermal oscillation and mechanical rotation. Tonight, however, it returned, stronger, faster, and unmistakably structured. Across 3 continents, data analysts watched identical curves appear on their screens. The amplitude was small, less than 1% variation in brightness, yet perfectly synchronized from observatory to observatory. The interval had shortened dramatically, from 27 minutes to just under 9. The new frequency wasn't harmonic with the old, it represented an entirely different mode of behavior. For astrophysicists accustomed to predictable periodicities, this was more than an anomaly. It was evolution. At the Harvard-Smithsonian Astrophysical Observatory, Dr. Marcus Llewellyn described the waveform as a coherent beacon with an adaptive heartbeat. His analogy wasn't poetic. Fourier analysis revealed each pulse to contain layered harmonics, 3 dominant peaks recurring in ratios of 1 to 2 to 4, repeating with mathematical precision. The pattern persisted through atmospheric distortion, cloud interference, and instrumental filtering. In other words, it was intrinsic to the source. NASA's Solar Dynamics Observatory cross-checked the light curve with solar activity logs. No corresponding flares, coronal mass ejections or magnetic disturbances matched the timing. That ruled out solar reflection. The emission was self-generated. Even more intriguing was its energy stability. Each pulse carried identical photon counts within a tolerance of 0.03%, suggesting real-time amplitude control. At ground level, smaller telescopes, those used by private research groups and amateurs, began confirming the same rhythm. Their sensors, far less sensitive than professional arrays, should have drowned in background noise. Yet the pulse cut through clearly, even on low-resolution detectors. This meant the signal wasn't faint, it was coherent, projecting with phase alignment across vast space, the way lasers maintain focus over great distances. By noon, speculation consumed the research networks. Some physicists proposed that 3I Atlas had entered a resonant state with the Sun's magnetic field, producing cyclic energy discharges. But such discharges typically degrade, not sharpen, over time. Others suggested a gravitational lensing effect, where another body periodically magnified its light. That too was dismissed. Orbital models showed no such alignment possible. What remained was the unsettling hypothesis that the object itself was generating the rhythm, adjusting internally, as if recalibrating. The pulse wasn't random. When plotted over time, slight variations in amplitude formed a secondary envelope, a larger wave modulating the smaller ones. It resembled amplitude-modulated radio transmission, where information is encoded not in the frequency, but in the strength of each oscillation. To test this, analysts applied digital demodulation techniques used in communications engineering. The results were ambiguous but tantalizing. Sequences of repeating numerical ratios, 17 of them, recurring every third cycle. No known natural mechanism produces numeric periodicity with that precision. At CERN, a data pattern team compared the ratios to known atomic structures. They didn't match any spectral line spacing, but did align loosely with harmonic patterns seen in quantum oscillator simulations, systems designed to stabilize energy flow. If accurate, it would mean 3E Atlas wasn't releasing energy chaotically, it was managing it. Within hours, the community splintered into 2 camps. One insisted the pulse was mechanical, an internal mass redistribution or rotational stabilization akin to a spacecraft firing attitude thrusters. The other believed it was electromagnetic feedback, a coupling between charged dust and magnetic fields generating a stable oscillation. Both explanations failed the simplest test. Neither accounted for the rhythmic precision nor its global synchronization. Then came the revelation from the solar orbiter. Using high-cadence imaging, the probe recorded slight luminosity gradients forming concentric bands around 3I Atlas during each pulse. The rings expanded outward like ripples, dissipating into the solar wind. They weren't material ejecta, their velocity exceeded particulate motion, but energy shells, transient and luminous. Their uniform spacing matched the pulse frequency exactly. When modelled, the effect resembled a controlled energy release followed by rapid field collapse. In terrestrial terms, it looked less like combustion and more like calibration, a system testing and adjusting itself with each cycle. The metaphor circulating among researchers was simple. It's checking its pulse. By late evening, NASA's internal discussion boards were filled with cautious phrasing: phase-modulated emission, self-harmonic coherence, active stabilization. Public statements, however, remained restrained. The official bulletin described the event as recurrent optical modulation of unknown origin. What unsettled many was what came next. Because as the pulses continued, a new discrepancy emerged between instruments measuring temperature and those measuring brightness. The two should correlate perfectly, hotter objects shine brighter, yet now for 3I Atlas, that relationship broke apart completely. The first sign that something was wrong with the thermal readings came from the James Webb Space Telescope. Its near-infrared spectrometer, which had been continuously tracking 3I Atlas since the start of the pulse event, showed a progressive cooling trend. an apparent drop of several degrees Kelvin during the brightest phase of emission. That on its own was bizarre enough. Luminous bodies brighten when they heat up. They do not dim thermally while shining more intensely. Yet, as data from SOHO and the Solar Orbiter arrived, an even stranger contradiction emerged. Both solar probes, using radiometric instruments tuned to ultraviolet and extreme ultraviolet ranges, recorded a simultaneous increase in thermal output. According to their sensors, 3i Atlas was getting hotter, much hotter, precisely during the same interval when Webb's instruments registered cooling. It was as if two versions of the same object were behaving in opposite thermal directions, depending on which wavelength you used to observe it. The effect was so counterintuitive that most analysts assumed calibration failure. They rechecked filters, realigned baselines, and ran cross-tests against known solar objects. The instruments performed flawlessly. That forced researchers to confront a disquieting conclusion. The data was correct. The object was simultaneously heating and cooling in different parts of the spectrum. When plotted together, the readings revealed a sharp divergence, an upward slope in ultraviolet, a downward curve in infrared, both pivoting around a narrow band of visible light that stayed oddly stable. That kind of spectral bifurcation is not found in nature. Even quantum materials under laboratory conditions exhibit uniform thermal transitions across bands. Here, however, the curves pulled apart as if two distinct systems were competing for energy within the same body. At the Harvard Astrophysics Center, a quiet discussion began around the concept of energy phase segregation. The idea, still speculative, proposed that 3i Atlas might be partitioning energy internally, routing high-frequency radiation outward while suppressing low-frequency heat emission. The closest terrestrial analogy would be a laser cavity or photonic crystal, where certain wavelengths are amplified and others dampened. But in nature, such cell activity requires structure. That was the implication no one wanted to say out loud: structural control. Something inside 3i Atlas was managing energy transfer with precision. Meanwhile, temperature maps reconstructed from multispectrum data revealed another surprise. The cooling zones corresponded spatially to regions of highest light emission. The object's brightest areas were paradoxically its coldest. In astrophysics, that inversion violates Stefan Boltzmann law unless active energy redirection is taking place. Essentially, unless the object is capable of moving heat away from where it is generated. The pattern deepened the longer the pulses continued. After each rhythmic flash, the hot and cold regions seemed to migrate, trading places in what looked like coordinated circulation. Scientists described it as thermal breathing. The process repeated with a rhythm synchronized to the light pulses but offset by several seconds, a deliberate delay, as though heat followed light in an organized cycle. When analysts ran temporal overlays, the heat lag consistently matched the time it would take energy to redistribute across a structure roughly 200 meters wide, the estimated size of 3i Atlas. That measurement stunned researchers. It meant the timing of the temperature shift corresponded exactly to the object's physical dimensions, not random fluctuations. Whatever mechanism governed the emission, it operated on a scale proportional to the body itself. ESA physicists considered a possibility that bordered on science fiction: internal field alignment. In advanced materials, it's possible to alter thermal pathways by manipulating electromagnetic lattices, forcing heat to flow along specific routes. If 3i Atlas exhibited anything like that, it would imply the presence of an organized electromagnetic framework, something designed, not accidental. To test this, radio observatories tuned to multiple frequencies during the next observation window. Though no classical signal emerged, a faint repeating pattern appeared in background noise around 60 MHz, exactly one harmonic below the optical pulse frequency. It wasn't enough to classify as transmission, but it proved that whatever caused the temperature gap also modulated nearby electromagnetic fields. In effect, 3i Atlas was not only defying thermal equilibrium, it was controlling its environment. By midday, the phenomenon earned its official designation, Thermal Divergence Event 3A, or TDE3A for short. Within hours, research networks filled with proposals linking it to phase conjugate reflection, negative temperature states, even quantum coherence at macroscopic scale. Each theory faced the same obstacle: scale. No natural body that size could sustain quantum effects long enough to manifest global thermal inversion. The question evolved from how can it do this to what allows it to. The leading hypothesis emerged from an unlikely source, University of Oslo's Magnetoplasma Lab. Their researchers pointed out that the ionized dust surrounding 3I Atlas could act as a resonant shell, amplifying certain frequencies and damping others, creating an artificial separation between radiation types. If true, 3I Atlas wasn't changing temperature internally. It was using its surrounding material as an active filter, manipulating how it appeared across spectra. But even that model fell short of explaining the synchronization. The thermal gap didn't fluctuate randomly. It followed a perfect 9-minute rhythm, locked precisely to the new pulse cycle. That linkage between light and heat implied direct feedback, a monitoring system of sorts. As night approached, global attention turned toward ground-based observatories. Amateurs began to contribute again, their smaller telescopes providing an independent check against professional data. What they found confirmed everything. Visible brightness remained stable while infrared faded steadily away. Even backyard instruments, crude compared to space telescopes, recorded the paradox with shocking consistency. By evening, the anomaly reached its second stage. The pulses stopped, the light stabilized, but the temperature gap did not close. Infrared remained suppressed. Ultraviolet continued to climb. 3I Atlas now radiated as if divided against itself, a cold shell emitting hot light. For the first time since discovery, scientists could not agree whether they were watching a physical object or an active system, something self-regulating, perhaps even adaptive. And then, just as the data began to settle, new observations from Earth-based telescopes brought yet another revelation, one that ruled out instrument error for good. When twilight fell over the Western Hemisphere, telescopes from Chile to Hawaii pivoted toward the coordinates of 3I Atlas. The air was clear, the moon low, and the object's location was ideal for optical visibility. Within minutes, confirmations began streaming through amateur astronomy networks. 3I Atlas was visible to ground-based instruments, and its behavior matched exactly what space-based observatories had reported. The first to detect it was the Cerro Tololo Inter-American Observatory in northern Chile. Their 4.1-meter mirror captured a faint but distinct object, moving against the solar background, glimmering with steady luminosity rather than a comet's diffuse tail. In the live feed, a thin oscillation in brightness appeared every 9 minutes, the same rhythm already logged by orbiting sensors. Nothing like it had ever been recorded optically from Earth. Minutes later, similar results emerged from Keck Observatory in Hawaii, La Palma in the Canary Islands, and Mount Stromlo in Australia. Each confirmed not only the existence of the pulse but also its global coherence. The moment one telescope registered the brightening, every other site recorded the same phase within milliseconds. That synchronization, observed now through entirely different instruments, destroyed the last refuge of skepticism. Whatever was happening around 3I Atlas was real. Not noise, not calibration drift, not sensor error. For many observers, the visual experience was unsettling. Through adaptive optics, 3I Atlas didn't shimmer like a comet or asteroid. Its glow had sharp edges, a confined halo rather than a spreading tail, as though its light was being shaped or contained. Some astronomers described it as a breathing sphere, expanding imperceptibly with each pulse before contracting again, the entire object oscillating in size by fractions of a percent. That motion, though microscopic, was mathematically measurable, and it coincided perfectly with the previously documented temperature and light cycles. The confirmation came with another discovery: subtle reflections in Earth's upper atmosphere. Several radio observatories, including the Arecibo Successor Array and the Canadian Hydrogen Observatory, reported transient electromagnetic disturbances synchronized to the optical pulses. These weren't typical ionospheric echoes from solar radiation. They were narrow-band reflections matching the frequency modulation detected in earlier emissions. The energy arriving from 3I Atlas appeared to be interacting with Earth's magnetic field in real time, a faint, mirror-like feedback effect. At first, this phenomenon was dismissed as atmospheric coincidence, but as observatories compared data, a distinct pattern emerged. The reflections only appeared during peak luminosity, and always with a 1.3-second delay, the time it would take light from the object to reach Earth and reflect back through the ionosphere. That delay was consistent across every location, suggesting the pulse carried enough coherence to survive the journey, strike the atmosphere, and return measurable echoes. The global coordination stunned the astrophysics community. For the first time, an object beyond the orbit of Mars was visibly altering electromagnetic behavior in Earth's atmosphere. Researchers began to refer to it informally as the mirror effect. It was as if 3i Atlas had briefly illuminated the planet itself in a wavelength tuned for response. Meanwhile, high-speed photometry from the Gran Telescopio Canarias detected something even stranger. During one of the pulses, a secondary spike appeared. A smaller, faster flicker nested inside the main rhythm. This subpulse lasted less than 1/10 of a second, but repeated at precise intervals across multiple observatories. The ratio between main pulse and subpulse frequency was exactly 9:3:1, the same harmonic structure identified weeks earlier in its spectral modulation. This discovery tied together every prior anomaly: the synchronization event, the rhythmic modulation, and the temperature gap. The object was operating with mathematical precision across multiple domains: optical, thermal, and electromagnetic. The repetition was too structured to be random, yet too subtle to be overt signaling. If intentional, it was not communication as humans understand it, but calibration, a system aligning itself with environmental feedback. As the hours passed, ground-based measurements added depth to what space telescopes could not see. Spectroscopic imaging revealed fine filaments of ionized gas around the object, glowing faintly in the ultraviolet. Unlike a comet's tail, these filaments moved inward, not outward, spiraling toward the core. That motion contradicted all expectations of solar wind pressure. Instead of being pushed away by sunlight, the material appeared to be drawn back in. Some physicists speculated that 3i Atlas might be generating its own local magnetic containment field, pulling ionized particles toward it. The more data accumulated, the more one conclusion took shape. 3i Atlas was not passive. Its behavior was active, adaptive, and self-regulating, characteristics belonging more to systems than to stones. The phrase autonomous process began to circulate among research circles, though no one dared use it in official publications. At midnight, a final observation cemented the mystery. As the object passed behind a dense region of solar wind, its luminosity dimmed, but the pulse continued at full strength, unaffected by scattering or interference. That meant the emission was not purely optical. It had components immune to environmental absorption, perhaps extending into spectra not yet measured. In one coordinated moment, every telescope, professional and amateur alike, confirmed the same reality. The light, the pulse, the synchronization, the reflections, all converged into a single, undeniable pattern. 3i Atlas was exhibiting global coherence across space-based and Earth-based observation platforms. For astrophysics, this was no longer an isolated phenomenon. It was an event, a system-wide occurrence, measurable across every layer of observation. And as dawn approached in Europe, another layer of the puzzle appeared, quietly recorded in magnetometer readings across the planet. Earth's own magnetic field had begun to oscillate, faintly, rhythmically, in tune with the pulse of 3i Atlas. At 2:14 UTC, the first indications came from a network of geomagnetic observatories across Scandinavia. The readings were small, microtesla fluctuations, barely above baseline noise, yet they pulsed in exact sync with 3i Atlas's light rhythm. Over the next hour, magnetometers as far apart as Canada, Japan, and South Africa reported the same oscillations. Each station, isolated and operating under different calibrations, showed identical timing offsets. It was not a coincidence of weather or solar interference. It was a global magnetic ripple, faint but measurable, that arrived every 9 minutes and decayed with surgical precision. The discovery forced researchers to confront a question that had been growing since the night of the synchronization event. Could 3i Atlas be interacting directly with Earth? The notion seemed absurd. The object was tens of millions of kilometers away, smaller than most minor asteroids, and surrounded by solar plasma that should have dampened any coherent field. Yet data now showed that its emissions were not only reaching Earth's ionosphere, but leaving a fingerprint in the planet's magnetic envelope. At first, the effect was treated as an echo, the logical explanation being that Earth's upper atmosphere was reflecting part of the signal, creating feedback visible to magnetometers. But when analysts modelled the delay between emission and response, they found it didn't fit. A simple reflection should return at the speed of light, roughly 10 minutes after the pulse. Instead, the magnetic ripple appeared ahead of schedule, by nearly 2 minutes. The signal was not a bounce, it was an induction. Something in the pulse was coupling directly to Earth's magnetic field, as though skipping the physical distance between them. That impossible lead time became known as the reflection problem. The term, however, was misleading. What scientists were seeing wasn't reflection in the mirror sense. It was resonance, a sympathetic vibration linking distant systems. Similar effects exist at microscopic scales, such as electron spin coupling or quantum entanglement, but never across astronomical distances. The idea that an interstellar object could synchronize with Earth's geomagnetic frequencies bordered on the heretical. At NASA's Goddard Space Flight Center, the geomagnetism team tried to trace the source using satellite-based magnetometers aboard the Themis array. They expected to see the signal dampen with altitude. Instead, they found it strengthened between the ionosphere and magnetopause, peaking at roughly 60,000 kilometers above Earth, a region where solar wind pressure and Earth's field balance in unstable equilibrium. The implication was staggering. The pulse from 3I Atlas wasn't being reflected off the atmosphere. It was being received by a standing resonance already present around the planet. Further analysis revealed a second layer to the problem. The induced magnetic oscillations were not uniform. They followed a longitudinal pattern, strongest above the Pacific and weakest near the poles. That distribution mirrored the path of the solar wind, the stream of charged particles flowing from the sun. Somehow, the pulse interacted with that stream, modulating it just enough to shape how it touched Earth's field. The energy involved was minuscule, yet its coordination suggested intelligence or, at the very least, precision feedback. At the Max Planck Institute, physicist Elena Koenig proposed a model she called plasma coherence transfer. In her simulation, a coherent electromagnetic field, like the one produced by 3I Atlas's pulse, could phase lock to the sun's magnetic flux lines. If the pulse's frequency matched the natural oscillation of those flux tubes, it might ride them, transmitting structure through the solar wind like sound through a wire. Such a mechanism would explain both the timing and the global coherence. It would also mean the signal wasn't directed at Earth intentionally. It was simply following the natural architecture of the solar magnetic field. And Earth happened to be in its path. But the model couldn't explain one crucial observation. The reflections detected in the ionosphere weren't just synchronous. They carried the same fine-scale modulation as the original emission, the microscopic waveform discovered days earlier. When the data was amplified and slowed down, the returning signal revealed a repeating structure, almost like a digital checksum verifying data integrity. In other words, the echo wasn't random interference, it was a confirmation. That revelation spread quietly through encrypted research networks. The idea that 3I Atlas's light contained embedded verification patterns, and that those same patterns appeared mirrored in Earth's ionosphere, challenged fundamental physics. If correct, it meant the system wasn't broadcasting blindly into space. It was engaging in a closed feedback loop with its own reflection. Several labs attempted replication. In Greenland, a team using ELF, extremely low-frequency antennas, detected matching phase shifts in the sub-1 Hz range, corresponding exactly to the envelope frequency of the optical pulse. The data indicated that a portion of the pulse energy was being converted into ultra-low-frequency magnetic oscillations, the same band Earth's field naturally resonates within. The object wasn't simply visible light, it was a full-spectrum modulator, reaching across electromagnetic scales to establish resonance. For scientists, this was an existential problem. If 3I Atlas could couple energy across that many frequencies simultaneously, it operated under principles unknown to human technology. Its coherence defied thermodynamics and dispersion alike. And if it could induce patterns in Earth's magnetic field, it meant the planet was now part of the experiment, knowingly or not. Publicly, agencies remained silent. Privately, observatories received instructions to continue recording without commentary. Government monitoring satellites were repositioned. The military classification solar interference event began appearing in data-sharing protocols, an administrative way of hiding the incident in plain sight. But inside research circles, the tone shifted again. The reflection problem had revealed something no one wanted to admit. 3I Atlas wasn't broadcasting outward. It was interacting with what observed it, adjusting, responding, and maintaining resonance through the very act of observation. And as scientists debated whether the phenomenon was natural or engineered, the next phase of the anomaly began to manifest. This time not in the light, not in the magnetosphere, but in the digital systems used to record it. The first report arrived from the European Southern Observatory at 3:07 UTC. Their automated archiving system, responsible for storing live telescope telemetry, froze mid-transfer. Operators assumed a server crash, but when technicians rebooted, they found something worse. The previous 12 hours of 3i Atlas data were intact but unreadable. Every file, from spectral logs to magnetometer traces, displayed identical checksum mismatches, as though corrupted in the exact same way. Within the next 30 minutes, observatories in Hawaii, Chile, and Japan began reporting the same failure. Different hardware, different encryption standards, but identical results. Normally, data corruption has a signature. It might affect random bits, interrupt files midstream, or delete header information. This was different. Each corrupted file contained the same checksum error, an integer offset by exactly 8,192 bytes. The pattern was too precise to be random. To make matters stranger, none of the affected systems were network linked at the time. The lockout appeared spontaneously across isolated machines that had no direct communication pathways. At NASA's Goddard Center, engineers compared the damaged datasets and found a deeper pattern. The corrupted segments corresponded precisely to the timestamps of the synchronization pulse, the same moments when the magnetic reflections peaked. It was as if whatever passed through space had also passed through the digital systems that observed it, imprinting itself on the data infrastructure. Cybersecurity teams were called in, their first assumption a coordinated intrusion. But logs showed no evidence of external access, no unusual IP activity, no file transfers, no administrative overrides. The data wasn't stolen or deleted, it had been altered in place all at once down to the storage parity layer. One analyst described it bluntly. The corruption behaved like radiation, not code. In the following hours, attempts to restore the files only deepened the mystery. Backup servers, stored offline, sealed in isolated facilities, showed the same corruption when powered on for recovery. Even optical discs recorded days earlier now produced identical checksum errors. Somehow the pattern had propagated backward through storage media. That defied the logic of both hardware and time. By dawn, the event had acquired a name, the data lockout. The phrase came from an internal memo circulated by the European Space Agency. It read simply, "Do not attempt additional restores. The data is present but inaccessible. Treat it as physically encrypted." That word, encrypted, triggered a wave of speculation. Could the corruption itself be a form of encryption? Some data scientists proposed that the pattern wasn't random noise but restructured information, potentially a translation or response to the data it overwrote. They noted that the 8,192 byte offset corresponded to a power of 2, a number frequently used in digital architecture. If 3i Atlas had somehow interacted electromagnetically with the hardware recording it, the result might look like deliberate bit-level modulation. At CERN, researchers tested this theory by analysing bit streams from damaged files. When they plotted the corrupted sections as binary waveforms, a faint rhythm emerged. It wasn't linear, it repeated every 9 minutes, the same as the light pulse. The corrupted bits weren't random flips, they formed a repeating sequence, consistent across all systems worldwide. In essence, every observatory's hard drive now contained an identical digital echo of 3i Atlas's pulse. The implications were staggering. No electromagnetic interference, no solar flare, no radiation storm could replicate such a precise global signature. Whatever caused it was not chaotic. It was patterned, organised, and seemingly selective. Only files containing active 3i Atlas data were affected. Files recording other celestial targets, Mars, Venus, or background star fields, remained perfectly intact. Within hours, this detail leaked through a technical forum used by independent researchers. The post was deleted within minutes, but not before screenshots spread. It read, "The object knows what we're watching." As the story spread quietly through private channels, several laboratories disconnected their telescopes from automated networks. Data collection returned to analog methods, direct optical feeds projected onto photographic plates. Ironically, this regression produced the clearest results yet. On film, 3i Atlas appeared stable, even serene, its faint glow uninterrupted by any visible anomaly. Only when the plates were digitized for analysis did the same corruption return. Somehow, the moment the data became binary, it changed. This discovery birthed a radical hypothesis, that 3i Atlas wasn't merely emitting electromagnetic energy, but manipulating information itself. The pulse's structure, embedded in the light, could be inducing resonance within microelectronic systems, subtle enough to alter data integrity without damaging hardware. In practical terms, it behaved as a message that could rewrite its own observation. By late afternoon, communication between observatories grew cautious. Data sharing halted, replaced by verbal summaries and encrypted physical couriers. The few scientists still exchanging digital packets noticed something unnerving. Some corrupted files were changing, slowly. Each time they were copied or analysed, new bit patterns appeared, self-correcting into increasingly coherent sequences. No one could explain how. At Cambridge, Dr. Sarah Chen's team discovered that when the binary data from multiple observatories was combined, the corruption aligned, like puzzle pieces completing a larger image. When rendered visually, it formed a waveform, a broad, symmetrical curve with sharp inflection points spaced in harmonic ratios. The same 3:2:1 pattern found in the light, the pulse, and the magnetic oscillations. It was the same signature, replicated now in digital form. The realization spread slowly but with growing dread. The lockout wasn't an accident or a malfunction. It was replication, 3i Atlas imprinting its behavior across every system that studied it. In effect, the act of observation had created copies of its pattern embedded within Earth's own data infrastructure. By nightfall, entire observatory clusters had gone offline, citing data quarantine. The phrase appeared again and again in internal communications, a polite way of saying what many feared. The data was alive, in the informational sense. And as global monitoring turned quiet, another silence emerged, this one deliberate. Major agencies stopped issuing updates, press channels went dark, the world's attention moved elsewhere. By November 9th's end, it was no longer a question of whether something extraordinary had occurred, it was how much of it would be allowed to reach the public. What began as scientific confusion was now a coordinated quieting. Press releases from the European Space Agency, NASA, and JAXA all arrived within hours of each other, carrying nearly identical phrasing. Data from ongoing solar object observations remains under review pending calibration. The timing was too precise to be coincidence. The message was clear: say nothing, admit nothing, wait for instructions. At the same time, the open telemetry feeds that amateur astronomers relied on began to fail. NASA's SOHO data stream cut out first, replaced by archived images labelled as routine maintenance. Then the Solar Dynamics Observatory's ultraviolet feeds switched to playback loops from earlier dates. Within 24 hours, no public system anywhere on Earth was transmitting live data from 3i Atlas. The entire global observation infrastructure had gone dark in a single coordinated maneuver. Inside research facilities, the silence was heavier. Teams who had worked together for months stopped sharing even basic information. Server rooms were sealed. Data terminals were placed under physical supervision. Researchers who asked too many questions were removed from internal channels or reassigned to non-critical projects. For those who remained, new directives arrived marked confidential, internal use only. They were told to catalogue all corrupted data under restricted classification, no cloud backups, no remote transfers, and no off-site discussion. At Cambridge, Dr. Sarah Chen's group, one of the first to identify the harmonic structure within the lockout data, was abruptly ordered to cease analysis. When she pressed for reason, the reply came through an encrypted email signed only with an administrative code: Containment priority, stop propagation. It was the first written acknowledgement that officials feared the data itself might spread. Parallel reports surfaced from the Harvard-Smithsonian lab, where analysts noticed something they hadn't seen before. Computers connected to internal observatory networks, but not directly handling the corrupted data, began exhibiting small random clock drifts, seconds of time vanishing, then reappearing. The pattern repeated every 9 minutes. When they isolated one of the affected systems and cut its power, the drift stopped. The implication was chilling. The synchronization anomaly had migrated from observation instruments into auxiliary infrastructure, manifesting as real-time temporal irregularities. Rather than release this finding, the observatory administrators classified it. From that moment on, no public mention of time drift appeared in any dataset or forum. Instead, internal correspondence shifted to cautious language: environmental oscillations, resonance coupling, localized feedback loops. Every description avoided the central word that researchers whispered privately: infection. To the few journalists following 3i Atlas since its discovery, the sudden blackout was obvious. Requests for comment were redirected through press liaisons. Public inquiry forums were locked or flooded with generic responses about data recalibration. A few independent scientists published small summaries on private blogs, noting that the pattern of silence across agencies resembled historical precedents, the same playbook used during classified aerospace incidents or deep space signal misinterpretations. Each of those posts disappeared within days, sometimes hours. Behind the scenes, a group of observatories in Chile, Spain and Australia formed what they called the Continuity Network. Their aim was to maintain limited, unclassified tracking of 3i Atlas using purely analog systems, telescopes disconnected from power grids, data recorded on photographic film only. Their findings confirmed the object's presence, though they noted a growing dimness. The light output had fallen slightly each night, but the pulse remained constant, unbroken. That stability meant the phenomenon was ongoing, even as the world stopped talking about it. Meanwhile, technicians monitoring deep space communications reported another layer of oddity. During the lockout event, the global deep space network experienced sporadic noise spikes at frequencies used to communicate with interplanetary probes. The signals weren't strong enough to disrupt communication, but they formed repeating interference bands in harmonic multiples of 9 minutes. The interference vanished when transmissions toward 3i Atlas were paused. Some technicians believed the pulses were echoing through communication infrastructure, not random interference, but cross-modulation. In one internal memo later leaked anonymously, an engineer wrote, "We're looking at feedback. The more we watch, the more it interacts." The silence isn't about secrecy, it's about containment. That phrase began circulating quietly through scientific circles, repeated in different forms: contain the feedback, contain the loop, don't let it synchronize. Whatever the true risk, decision-makers believed that 3i Atlas's influence could propagate through observation, through data, perhaps through attention itself, and so, one by one, observatories complied. Live observation ceased. Ongoing data sets were locked in encrypted archives. Even internal chatter dwindled until only a few encrypted backchannels remained. Small groups of scientists exchanging handwritten notes scanned and passed offline. But for all the silence, not everyone obeyed. Independent observatories, privately funded, often staffed by volunteers, continued their recordings. Without official access to the corrupted datasets, they built their own. What they found unsettled even the most cautious among them. In their analog recordings, subtle variations in 3i Atlas's luminosity revealed geometric changes, small structural shifts that didn't match its prior profile. The object, once roughly spherical, now appeared slightly elongated, its brightness distributed along a new axis. When compared frame by frame, the shift was not random. It resembled reconfiguration, as if internal layers were moving. The discovery was kept secret for only a day before leaking through encrypted forums, reaching the few scientists who still dared to share findings anonymously. For those who saw the images, the realization was immediate. The silence had bought time, but not clarity. 3i Atlas was still active, still changing, and doing so under the cover of official blackout. The public remained unaware, the media uninterested, the agencies wordless. But inside laboratories and darkened offices across the world, one truth hung unspoken yet universal. The quiet wasn't meant to protect people from panic. It was to hide how little anyone truly understood. When the first unfiltered composite of 3i Atlas's latest observation emerged, it wasn't from a government lab or major telescope array. It came from a small private observatory in southern Spain. The team had continued running a series of autonomous offline sky tracking scripts, unaware that official directives had suspended further observation. Their analog-to-digital converter compiled stored plates into a new composite image at dawn, and what appeared on the screen defied everything previously known about the object. The once uniform glow of 3i Atlas had fractured. Its outer contour, previously spherical with slight irregularities, now displayed angular features, faint ridges, parallel and evenly spaced, radiating from a central axis like the panels of a structure unfolding in slow motion. Within the inner halo, the light distribution wasn't random. It formed lines, intersecting at precise 60-degree intervals. The geometry was unmistakable, a hexagonal symmetry. Nature rarely builds perfect hexagons on this scale. At first, the researchers dismissed it as a data artifact, a photographic plate imperfection. But when they compared exposures from previous nights, the transformation was progressive. The pattern wasn't sudden, it had grown. Each subsequent frame revealed more defined edges, more symmetry, more internal structure. The team, aware of the sensitivity of their finding, encrypted the data and quietly sent it to a handful of trusted colleagues abroad. Within 12 hours, 3 other observatories confirmed identical features. The change was real. At the Harvard-Smithsonian Center, where Dr. Marcus Llewellyn's group had already been analysing the lockout data, the image forced a shift in approach. They began feeding the structural data into 3D reconstruction algorithms used in planetary mapping. When combined with telemetry from the last known pulse cycle, a pattern emerged. The hexagonal geometry wasn't random ornamentation. It followed stress lines consistent with load redistribution, the kind that occurs when a solid body adjusts its internal mass balance. If true, that meant 3i Atlas wasn't static, it was reconfiguring. The implications spread fast through the encrypted scientific backchannels. The first hypothesis came from a materials physicist in Kyoto: phase state transformation. In theory, certain exotic compounds under prolonged radiation can shift their internal lattice structures, rearranging molecular symmetry without melting or disintegrating. But no natural body of 3 Atlas's size could undergo such a controlled metamorphosis. The observed symmetry was too exact, too self-consistent. Others proposed a more unsettling idea: self-stabilization. The periodic pulses, the temperature bifurcation, the synchronized electromagnetic behavior, all could be components of an active stabilization process. In this model, 3i Atlas wasn't changing randomly, it was compensating. Something inside it was balancing external forces, altering shape to maintain equilibrium within the solar wind. At the University of Cambridge, Dr. Sarah Chen's team noticed something even more compelling. When they overlaid the hexagonal geometry with the earlier harmonic ratios from the corrupted data, 3:2:1, the spatial proportions matched exactly. The ratio between the hexagonal edge length, the core radius, and the outer halo diameter mirrored the frequency intervals of the light pulses. Geometry and signal were linked. The object's structure appeared to encode the same mathematical relationships found in its emissions. The pattern's precision raised a question no one could comfortably ask. Was this behavior the result of physical laws, or of design? Publicly, no one dared use the word engineered. Privately, it became unavoidable. Several analysts within ESA and NASA had long argued that 3i Atlas's early trajectory, particularly its deceleration phase, already violated known cometry mechanics. Now, with the discovery of structural geometry, that earlier anomaly gained new context. Deceleration could have been deliberate. The object might not have been slowing naturally, but reorienting, adjusting shape to regulate thrustless motion through solar radiation pressure. If this was true, then what the world had been watching for weeks wasn't an asteroid, or a comet fragment, or even a dormant interstellar relic. It was an adaptive object, capable of responding to its environment in real time. The structure's internal symmetry also revealed something unexpected. Using filtered spectroscopy, analysts detected distinct polarization patterns along the hexagonal ridges. These variations corresponded to controlled light scattering, as if certain surfaces were reflecting deliberately while others absorbed. That kind of anisotropy, direction-dependent behavior, is characteristic of engineered materials like metamaterials or phased optical arrays. The light wasn't merely reflecting off rough rock, it was being manipulated. But the deeper scientists looked, the stranger the proportions became. The hexagonal ridges weren't symmetrical in length. They curved slightly inward, forming what appeared to be a spiraling pattern converging toward the object's northern pole. The design, if it could be called that, resembled a massive gyroscopic lattice, optimized for rotational balance, yet no rotation was detected. The entire structure maintained perfect stability, even under varying solar pressure. When simulations attempted to replicate this configuration, one consistent result emerged. The geometry distributed stress uniformly, minimizing internal strain to near zero. That's not a random mineral formation, that's optimization. As these findings circulated privately, agencies doubled down on containment. Research groups were instructed to delete working copies of reconstruction models. Some complied, others didn't. Among the few that refused silence was an independent physics consortium based in Toronto. Their analysts published an anonymous white paper to a peer-to-peer network, titled simply Morphological Dynamics of Object 3I Atlas. The paper's central claim was bold. The observed hexagonal restructuring is indicative of deliberate harmonic stabilization. The system behaves as if aware of its structural resonance. It was online for less than an hour before disappearing. Despite the suppression, the transformation continued. By evening, new images showed the central axis elongating further, the structure narrowing slightly, as though preparing for a phase transition. The reflected light became polarized, producing flickers invisible to the naked eye but easily measurable through photometric filters. Each flicker corresponded precisely with the 9-minute pulse interval, and then, just as quickly as it began, the restructuring slowed. The pulse weakened. The object's luminosity dipped to half its previous level and stabilized. The solar wind around it calmed. For a brief moment, scientists thought the anomaly was ending, but in the data that remained uncorrupted, one final metric shifted quietly beneath notice. The object's orbital trajectory, once stable, once predictable, had moved. Not by much, but enough. Calculations confirmed that 3I Atlas's path through the solar system had deviated by measurable degrees, a change impossible without external thrust or internal mass redistribution. Whatever had been happening within it was no longer theoretical. The shape had changed. The geometry had stabilized. And now, the orbit itself was different. Something inside 3I Atlas had moved. The first orbital deviations were subtle, small enough to hide within the noise of solar wind variation. Yet as the data accumulated, the margin widened. What began as a fractional discrepancy became undeniable by mid-morning on November 9th. 3I Atlas had shifted course. Its trajectory no longer matched gravitational predictions, even after accounting for solar radiation pressure, plasma drag, or magnetic perturbation. The deviation wasn't random drift. It was smooth, continuous, and deliberate in character. The discovery came almost simultaneously from 3 different teams. At NASA's Jet Propulsion Laboratory, orbital analysts recalculated the object's path using combined inputs from SOHO, STEREOA, and the last available ground-based readings. Their model showed an unexpected increase in perihelion distance, the point of closest approach to the Sun, by 0.04%. It was as if the object had applied an invisible brake, slightly widening its orbit. Meanwhile, the European Space Operations Centre found the opposite. Their independent fit indicated a marginal inward deflection. When both models were overlaid, they didn't cancel. They formed an oscillation, a slow, rhythmic modulation of position synchronized perfectly with the 9-minute pulse. This phenomenon soon earned its name, the orbital paradox. In classical mechanics, an object's path can change through 2 mechanisms: external force or internal mass redistribution. No external forces could account for the pattern. Solar wind fluctuations lacked both directionality and regularity. That left only one possibility. 3I Atlas was changing its own centre of mass. When the structure images from the previous chapter were re-examined in light of this, the geometry's purpose seemed clearer. The hexagonal reconfiguration, once thought purely aesthetic or incidental, might be part of an active stabilization system, a form of mass management that allowed the object to steer without thrust. Each structural shift could subtly move internal mass, altering the gravitational balance and redirecting momentum. In essence, 3I Atlas was piloting itself through structural modulation. For days, scientists had argued over whether the object's pulses represented communication, energy management, or mere resonance. Now a fourth theory emerged: propulsion through resonance. In this model, the pulses generated controlled magnetic fields, interacting with charged solar particles to produce minute directional forces. When combined with mass redistribution, those forces could compound over time, gradually altering orbit. The mathematics worked. The energy requirements, though extreme, matched the observed temperature anomalies. At Cambridge, Dr. Sarah Chen's team modelled the effect using harmonic resonance equations. When the light pulse frequency was applied to charged plasma densities consistent with the solar environment, their simulation produced measurable drift, not in the direction of the Sun or away from it, but tangentially along the orbital path. The drift pattern mirrored the real data. The model implied that the pulses weren't waste energy. They were controlled emissions, functioning like periodic magnetic sails. But what made the paradox so disturbing wasn't the motion itself, it was its precision. Natural processes produce jitter, inconsistency, and noise. The orbit of 3I Atlas, however, adjusted with smooth mathematical grace, as if following a pre-computed trajectory. Over the course of 12 observation hours, the object's velocity changed by exactly 0.002%, corresponding to a delta V of 3.8 meters per second, the kind of controlled acceleration used in spacecraft maneuvering burns. At the Jet Propulsion Laboratory, analysts fed these figures into orbital prediction software used for artificial satellites. The results were astonishing. 3I Atlas's new path wasn't chaotic but optimized. The revised trajectory reduced its exposure to solar radiation by 3%, stabilized its inclination relative to the ecliptic, and placed it on a near-perfect intercept with a gravitational null zone between Earth's and Mars's orbital fields, a region known as a Lagrange corridor. No natural object could have calculated or achieved such efficiency by chance. Meanwhile, an independent review by the University of Bologna noticed a secondary effect. The slight shift in orbit altered the timing of the reflected pulses reaching Earth. The echoes in the ionosphere began arriving earlier than predicted, by a full second. The synchronization anomaly, long considered stable, had evolved once again. It now tracked the object's changing position, as if compensating automatically. Whatever link connected Earth's magnetic field to 3I Atlas's pulse had adapted to the orbital change in real time. For some, this was the breaking point. The idea that an interstellar object could self-correct its orbit in coordination with electromagnetic resonance bordered on sentient behaviour. Yet the more cautious among the scientific community clung to non-intentional explanations: feedback resonance, phase coupling, emergent stabilization. But none could explain the precision or predictability. At ESA headquarters, engineers ran diagnostic tests on prior space missions to rule out data interference. They found that during the orbital shift, several spacecraft, including Solar Orbiter and Parker Solar Probe, experienced temporary fluctuations in orientation sensors. Gyroscopes showed tiny but synchronized torque deviations matching 3I Atlas's pulse interval. The spacecraft themselves had briefly responded to a force no one could identify. Inside the classified briefings that followed, a single theory dominated: gravitational modulation through internal field manipulation. If 3I Atlas could oscillate its internal mass distribution, say by shifting density across its geometry, it could generate tiny self-induced gravitational gradients, enabling thrustless trajectory control. Such a concept, once relegated to theoretical propulsion research, was now being considered seriously. Still, the implications extended far beyond mechanics. If the orbital adjustment was deliberate, then someone, or something, had determined a destination. And the data showed that the new path wasn't aimless. Within days, if the trajectory continued unaltered, 3I Atlas would cross the heliospheric current sheet, the vast undulating boundary dividing the Sun's magnetic hemispheres. Crossing that region would expose the object to powerful electromagnetic flux, enough to disrupt or destroy any ordinary structure. Yet the object appeared to be preparing for it, adjusting its geometry precisely for the transition. When asked why any system, natural or not, would seek such a dangerous corridor, Dr. Chen gave a quiet reply during an off-record interview. Because that's where you'd hide a signal. Her reasoning was simple but haunting. The heliospheric current sheet is the noisiest region in the solar system, flooded with plasma interference. Any emissions passing through it would vanish from ordinary detection. If 3I Atlas was preparing to communicate or vanish, that would be the place to do it. The following night, tracking stations confirmed the drift had accelerated. The object's velocity curve now showed slight undulations, gentle surges every 9 minutes, perfectly timed with the pulse. It was no longer metaphorical. 3I Atlas wasn't just emitting rhythm, it was moving to its own beat, and as it approached the edge of the heliospheric corridor, researchers realized what that motion truly meant. The shift wasn't random evolution or orbital decay. It was intent made visible in physics, direction encoded in movement. The first reaction wasn't public. It began inside control rooms. When orbital modelling confirmed that 3I Atlas was actively altering its path, agencies shifted from scientific analysis to strategic posture. The European Space Agency labelled the event Level 3 contingency, non-gravitational propulsion detection. At NASA, an internal directive froze all public communication until interagency synchronization could be achieved. Even the language of those memos was carefully constructed. No mention of intelligence, no reference to control, only the phrase coherent orbital modulation inconsistent with natural dynamics. Behind closed doors, the tone was very different. At the Pentagon, the Department of Defense requested an emergency teleconference with NASA and the National Reconnaissance Office. The concern wasn't scientific curiosity, it was trajectory. If the object's path was under control, its next movement could, in principle, be directed toward anything, even Earth. Though probability models still placed it far from intersecting, the simple fact that it could adjust at all redefined it from a celestial object to a potential vehicle. While defense agencies deliberated, scientists faced a crisis of integrity. Years of observation were now subject to classification. Research groups were required to hand over archives, and even encrypted drives were seized for coordinated review. Public data repositories, once open to amateur astronomers and university networks, began returning 404 errors or data pending recalibration messages. Within 48 hours, the global dataset of 3I Atlas was inaccessible to anyone without clearance. Yet information leaks never stay contained for long. In Tokyo, a small astronomy blog posted screenshots of the final confirmed orbital parameters before the blackout. The image showed a path bending toward the heliospheric current sheet, annotated with a chilling caption, "It's steering." Within hours, the post went viral. News outlets ignored it at first, assuming another conspiracy theory in the endless churn of online rumour. But when the blog was taken offline by its host without explanation, attention grew. Forums, image boards, and independent science pages erupted with speculation. Social media filled with amateur translations of scientific papers, grainy telescope images, and frantic videos claiming to have captured the pulse visually. None were verifiable, but the atmosphere of quiet dread spread quickly. In the absence of official explanation, imagination filled the void. Governments responded predictably, with silence. Press questions were deflected to ongoing reviews. Even private institutions began avoiding the topic. The Harvard-Smithsonian Observatory cancelled its scheduled press briefing without notice. The European Southern Observatory's public data feed went permanently offline. To the public, it looked like disinterest. To those inside the system, it was the clearest signal of fear. Within the scientific community, fissures appeared. Some researchers began leaking fragments of information under pseudonyms, orbital simulations, photometric reconstructions, uncorrupted spectral data. Most of it was incomplete, but enough patterns aligned to confirm what the agencies already knew. 3I Atlas's motion wasn't accidental. The harmonic pulse was now measurable not just in brightness, but in position. Each 9-minute interval coincided with a micro-adjustment in trajectory, like a pendulum guiding itself along an invisible track. Theories multiplied. Some called it an interstellar probe using radiation pressure as propulsion. Others insisted it was a natural body entering a resonant feedback cycle with solar magnetism. A small, quieter minority proposed something stranger, that 3I Atlas might be a relic of a self-regulating system, an ancient autonomous mechanism from deep space, reacting instinctively to the sun's influence like a living cell to heat. As scientists argued, politicians intervened. The United Nations Office for Outer Space Affairs called for an emergency session in Geneva. Officially, the agenda was coordination of observational assets. In reality, it was damage control. The few attendees later described the atmosphere as surreal, diplomats discussing an object they couldn't name, a phenomenon they couldn't explain, and an outcome they couldn't predict. The leaked minutes of that meeting revealed an uncomfortable truth. One line, attributed to a European delegate, read, "If it's adjusting trajectory, it has propulsion. If it has propulsion, it has control. If it has control, we must assume intent." The phrase, "assume intent," appeared again in US internal communications hours later, this time in a classified briefing between the Pentagon and NASA. By then, radar and optical tracking confirmed the trajectory shift had stabilized along a precise corridor cutting across the solar plane. The pattern matched no gravitational harmonics, no cometary debris routes, no natural resonances. It was clean, linear, and unerringly calculated. But the scientific community wasn't only watching 3I Atlas's position, they were watching its emission. As the object entered the heliospheric current sheet, its pulse changed character. The optical wavelength broadened, its amplitude flattening into a near-constant band. The rhythmic pattern that had defined the anomaly for weeks began dissolving into a continuous signal, low but steady. It was no longer pulsing, it was transmitting. The broadcast didn't resemble radio, light, or plasma waves in isolation. It was all three, layered. A broad-spectrum hum blanketed detection instruments centered on the same harmonics embedded in the corrupted data months earlier. The interference spread through deep space networks, corrupting unrelated signals from probes near Jupiter and Saturn. The pattern repeated across every affected system, its code unchanged. To the untrained observer, it was noise. To those who had followed the case from the beginning, it was continuity. The same triadic harmonic reappearing everywhere 3I Atlas touched, as if the object were writing its signature into the fabric of every system that tried to measure it. Publicly, governments downplayed it as magnetospheric interference. Privately, astrophysicists understood the scale of what they were seeing. 3I Atlas wasn't broadcasting to Earth, it was using the solar system as a resonator, embedding information into the medium of space itself. Theories that once sounded paranoid now read like caution. If the object could alter its orbit, affect magnetic resonance, and rewrite digital systems, then communication might not require words, frequencies, or signals. Observation itself could be the medium. By the time world governments agreed to resume limited tracking, it was already too late. The continuous emission had synchronized with solar rotation, spreading its harmonics through the heliospheric field. Every monitoring satellite within range recorded the same steady background pulse, faint but permanent, like a heartbeat embedded in sunlight. The object's orbit had stabilized, its shape fixed, its movement deliberate. The pulse had become the background of the solar system's data stream. The scientists who remained online summed it up in a phrase whispered through encrypted channels. It's no longer being observed, it's observing us. And yet, even that wasn't the final escalation. Because as the global silence deepened, a small team at the Lovell Radio Telescope in England detected something new in the noise. Faint structured intervals that didn't match any known transmission source. The harmonics were identical to 3I Atlas's signature, but the direction wasn't from the object itself. It was coming from within Earth's magnetosphere. The signal first appeared as a whisper in the static, a faint rhythm pulsing just below the range of human hearing. On November 9th, at 23:41 UTC, the Lovell Radio Telescope in Cheshire registered a recurring low-frequency oscillation while scanning the near-Earth magnetosphere. The team assumed it was residual interference from the solar storm that had flared earlier in the week, but the timing didn't match solar data. The pulses arrived every 9 minutes and 13 seconds, the same cadence that had defined 3I Atlas from the beginning. At first, the technicians thought the telescope was picking up an internal reflection of archived data. Yet when they switched receivers and frequency bands, the pattern persisted. More alarming, it shifted slightly in amplitude depending on the direction the dish faced. The source wasn't deep space, it was local, somewhere within Earth's own magnetic field. The team logged the anomaly and contacted ESA's Space Situational Awareness Network. Within hours, confirmation came from multiple independent instruments. Ground-based magnetometers in Norway, Chile and New Zealand all showed matching waveforms. The pulse wasn't isolated, it wrapped around the entire planet. A harmonic resonance had taken root within the magnetosphere itself. At first, the pattern seemed random, subtle rises and falls in amplitude. But when digital analysts at Cambridge applied spectral compression, something unexpected emerged. Within the wave envelope lay nested sub-patterns, repeating numerical ratios of 3 to 2 to 1, identical to the harmonic structure observed in 3I Atlas's optical emissions, temperature cycles, and data corruptions. It was the same mathematical DNA now embedded in Earth's electromagnetic environment. No one wanted to believe it. The logical assumption was human interference, overlapping radar signals, military communications, or satellite reflections. But signal triangulation ruled those out. The frequencies weren't in any allocated communication band, and the source location was inconsistent. It drifted across the magnetic field lines as though the signal itself were moving with the planet's rotation. By the early morning hours, the phenomenon had become impossible to ignore. NASA's magnetospheric multiscale mission, MSAM-S, which monitors plasma interactions between the Sun and Earth, recorded faint plasma density fluctuations corresponding to the pulse interval. The harmonics weren't just in the magnetic field. They were shaping the plasma environment itself, like invisible ripples passing through the upper atmosphere. The world's agencies had already imposed silence after the Orbital revelation, but this discovery spread too fast to contain. Leaked spectrograms appeared on encrypted research forums. One post from an anonymous engineer simply read, "The pulse followed us home. At the University of Kyoto, computational physicist Renito analysed the waveform sequence and found something even more disturbing. When the signal was slowed by a factor of 10,000 and mapped onto a temporal grid, it revealed organised symmetry, clusters of repeating intervals forming nested ratios. The structure wasn't random noise, it was ordered. When plotted visually, it resembled a lattice, geometric nodes connected by faint arcs, like a three-dimensional diagram of resonance across space." Ito compared it to phonon resonance patterns found in crystalline solids. The similarity was uncanny. In physics, such resonance diagrams describe how vibrations move through ordered structures. But there was no physical lattice here, only Earth's magnetic field. Something invisible was using the field lines as a framework, turning the planet itself into a resonant body. Meanwhile, communications engineers began reporting unusual interference in unexpected places. Undersea fiber cables showed minor signal desynchronization. GPS systems experienced momentary drift, not from solar activity but from rhythmic phase shifts matching the 9-minute interval. Even power grids recorded infinitesimal fluctuations in line frequency, repeating in the same rhythm, globally synchronized to within milliseconds. The effect wasn't destructive, it was orchestrated, controlled, as if whatever force emanated from 3i Atlas had reached equilibrium and begun stabilizing through the very networks it once disrupted. Some scientists proposed that this was an after effect, a natural resonance cascading through Earth's field, fading over time. But each day the amplitude subtly increased. The signal wasn't decaying, it was reinforcing, like a feedback loop that had found its own frequency and was now amplifying through the planet's electromagnetic skeleton. The most unsettling realization came from pattern analysis. When the waveform was converted into binary, peaks as ones, troughs as zeros, and sequenced over multiple cycles, the data produced repeatable clusters that bore statistical resemblance to information encoding. At first, it seemed random, but when the corrupted 3i Atlas datasets from the data lockout were cross-referenced with the magnetospheric signal, alignment appeared. The same binary patterns that had rewritten observatory hard drives were now emerging naturally in Earth's magnetic field. In other words, the same code that once lived inside the corrupted data now lived inside the planet. No one dared say it publicly, but the private consensus among the few researchers still sharing data was grim. 3i Atlas wasn't transmitting to Earth, it was replicating through it. The solar resonance had crossed a threshold where energy, magnetism and data merged into one feedback medium. The Earth had become a node in whatever system 3i Atlas represented. Then came a new twist. The Lovell team, still monitoring the pulse in real time, noticed a slow drift in phase. Each 9-minute cycle was shortening by fractions of a second. It was imperceptible to the public, but for those watching, it meant only one thing: synchronization. The pulse was aligning, locking into phase coherence with the Earth's rotation. The planet and the object were moving toward resonance, a harmonic unison that, if completed, could merge their electromagnetic fields into a single oscillating system. Theoretical physicists ran emergency simulations. The results were inconclusive, but one outcome repeated across models. If global magnetic coherence reached full synchronization, minor but measurable shifts in ionospheric density, radiation shielding, and atmospheric charge could occur. None of these effects were catastrophic. but all implied a reconfiguration of Earth's natural rhythms. It was as though the planet itself was being tuned. By now, agencies had stopped issuing any statements at all. The public narrative became fragmented, online speculation filled with hoaxes, false signals, and AI-generated conspiracies. But deep inside data centers, the remaining uncorrupted research teams understood the quiet truth. The pattern wasn't ending. It was adapting. The once external anomaly had embedded into Earth's systems, evolving from a distant astrophysical curiosity into a planetary phenomenon. And still, amid the silence, one final discovery emerged from a forgotten monitoring array in northern Canada. An old analog magnetometer, still operating on paper roll output, recorded a slight amplitude spike in the latest cycle, a small deliberate modulation at the peak of the waveform. At 300 hours UTC, the pulse vanished. Across every observatory still secretly online, the same thing happened in the same instant. The 9-minute rhythm that had governed weeks of observation simply stopped. Magnetometers flattened, light curves went silent, radio spectrograms dissolved into normal cosmic noise. For a few seconds, the world's instruments reported nothing unusual. It was as if the heartbeat of 3i Atlas had exhaled for the last time and slipped back into the void. But silence in science is never just absence. Within minutes, new anomalies appeared. Faint, synchronized deviations across otherwise unrelated systems. Seismographs registered micro-oscillations that had no geological origin. Deep-sea hydrophones, designed to record tectonic rumbles, picked up ultra-low frequencies previously associated with the magnetospheric pulse. Power grids compensated for invisible fluctuations that engineering software labelled as harmonic saturation, a phrase no one had ever seen before. Then came the visual confirmation. The solar orbiter's onboard coronagraph, one of the few instruments still transmitting live despite the blackout, caught a final image before its systems abruptly switched into safe mode. It showed 3i Atlas at the threshold of the heliospheric current sheet, its structure faint but unmistakably altered. The once solid geometry had begun to fragment into nested rings, concentric layers of light rotating around a hollow core. Each ring emitted a slightly different wavelength, forming a full spectrum of coherent colour, like the diffraction of light through a prism, but self-generated and perfectly aligned. Moments later, the object disappeared. No flash, no debris trail, no measurable acceleration. It simply ceased to reflect or emit anything detectable. Instruments that had tracked it for months saw only empty coordinates. It was gone, leaving behind nothing but the residual magnetic hum now threaded through Earth's own field. The world above remained calm. To the public there was nothing to see. No lights in the sky, no visible change. But within laboratories and data centers across continents, the silence carried a different weight. The harmonics embedded within the planet's magnetosphere had not faded, they had stabilized. The pulse was no longer an event, it had become a background constant, a steady resonance integrated into the Earth's electromagnetic spectrum. At Cambridge, Dr. Sarah Chen called it persistence without source. In her notes, later leaked anonymously, she wrote, "It's not transmitting anymore because it no longer needs to. The field itself remembers." For days, researchers watched as the planetary pulse held steady at a barely perceptible amplitude, woven seamlessly into the natural fluctuations of the geomagnetic field. It wasn't destructive, nor overtly active, but it was there, measurable, precise, unwavering. Every model predicted that without an external driver, the signal should decay within hours. It didn't. The amplitude remained constant, locked at 1 part in 10 to the 7th power, faint but immortal. In time, monitoring protocols changed. The anomaly was reclassified as a residual geophysical oscillation, a bureaucratic euphemism for the inexplicable. Projects studying it were quietly defunded, their data archived under digital containment. When journalists requested updates, agencies cited normal solar variation. The event officially had never occurred, but among those who had seen the unfiltered data, the silence carried an unspoken understanding. Whatever 3i Atlas had been, it hadn't vanished. It had transitioned. Its presence no longer resided in orbit, light, or structure, but in the field around the very planet that had observed it. For months afterward, subtle coincidences began to accumulate. Random synchronization between distant clocks, identical noise patterns appearing in unconnected radio systems, atmospheric interference following geometric ratios that echoed the object's old harmonic signature. None of it was dramatic enough to provoke alarm, but none of it belonged to chance. In a small private paper circulated among remaining researchers, a single paragraph summarised the growing unease. We have failed to define where the phenomenon ends. If interaction can occur through observation, and if the system can propagate through electromagnetic memory, then containment may be impossible. It is no longer an object, it is a condition. The condition, faint, silent, and continuous, became part of the background world. Its 9-minute rhythm, once audible to instruments, dissolved into frequencies indistinguishable from Earth's natural hum. Yet to those who had measured it firsthand, there remained the uneasy feeling that the data was still listening, that every network, every field, every signal carried within it a trace of something that had arrived, changed form, and stayed. And in the deepest hours of monitoring, when the instruments seemed quietest, some claimed to see a ghost pattern reappearing on their screens, faint, rhythmic, and impossibly precise. A single harmonic triad. 3, 2, 1. The same pattern that started it all. No one could say if it meant communication, completion, or remembrance. But one truth lingered, spoken quietly by scientists who could no longer publish, and engineers who could no longer admit what they'd seen. We never observed it. It observed us and left us carrying the echo. Then, as if written into the static itself, came the final realization that would haunt every mind touched by the event. If the field remembers, then we are part of what it remembers. And beyond the silent hum of the magnetosphere, somewhere past the heliospheric veil, the place where 3i Atlas vanished remains, empty, unlit, but resonant still. Months passed. The story of 3i Atlas faded quietly from memory, surviving only in obscure data logs and in the sleepless thoughts of the people who had watched it unfold. To the public it had been a passing curiosity, another headline lost in the static of the world's news cycle. To those who knew better, its absence was more haunting than its presence had ever been. By February, the last official report had been filed and buried. Satellite archives were sanitized, observatory databases replaced corrupted segments with synthetic datasets, reconstructed normal sky readings to preserve continuity. The global monitoring network resumed as if nothing had happened. Only a handful of researchers still checked the magnetospheric oscillations late at night, watching the faint 9-minute pattern that refused to die. It persisted, not loud, not growing, simply there, a heartbeat under the planet's skin. At first, the frequency drifted slightly, varying with solar wind. Then it began compensating, maintaining phase as if adjusting itself. Some called it a coincidence of natural resonance. Others whispered that the Earth had become part of a closed system still linked to something beyond the heliosphere. A feedback circuit with no known input. In March, a monitoring buoy in the South Atlantic detected a low-frequency electromagnetic anomaly. Its waveform matched the same harmonic ratios as 3i Atlas's last recorded emission. The signal was weak, submerged beneath oceanic noise, but coherent. When analysts triangulated its position, it originated not from space, but from deep beneath the surface, near the boundary of the Earth's core magnetic anomaly. There was no public mention of the finding. Only a single line appeared in an internal NOAA summary. Recurrent subharmonic pattern consistent with previously catalogued oscillation. Recommend continued passive observation. The phrase passive observation was a euphemism, a way of saying watch it, but don't touch it. Meanwhile, systems worldwide began showing subtle synchrony again. Air traffic radar, satellite telemetry, long-wave radio, all began drifting into shared phase coherence. For engineers, it was just calibration noise. For those who remembered, it was a shiver of recognition. The pattern was returning, faint but organised. In London, Sarah Chen's remaining notes were found sealed in a private locker after her quiet resignation. Inside was a small notebook, handwritten in code and formula, its final page containing only one line. The field is learning. No one knows what she meant. Today, 3i Atlas remains officially unobserved. No telescope lists its coordinates, no public archive records its last transmission. But when magnetometers are left running long enough, the analog ones, the kind that still use coiled wire and paper rolls, a faint signal continues to mark its rhythm. 9 minutes, 13 seconds, a perfect harmonic ratio, no longer strong enough to interfere, not weak enough to forget. Most scientists have moved on. The few who haven't describe the feeling as standing next to a sleeping animal, the knowledge that it could stir again at any time, without warning. Some have begun calling it the residual field, others refuse to name it at all. Every so often, a solar observatory catches a transient flare that doesn't match the sun's rotation, a flicker of geometry in the coronagraph too brief to catalogue. The images are always dismissed as instrument ghosts, but those who still compare them to the old archives notice something unsettling. The angles align, the ratios are the same. Whatever 3i Atlas became, it never truly left. It simply changed state, from object to pattern, to memory, to environment. The universe, it seems, keeps perfect records. In the end, no one could say exactly when it finished. There was no final pulse, no collapsing flare, no last data spike to mark an ending. The world simply drifted back into silence, its instruments returning to baseline, its skies unremarkable again. The archives would later call it a solar anomaly. Textbooks would file it beside forgotten comets and misinterpreted signals. The official record would speak only of calibration errors, atmospheric scattering, transient magnetic interference. But the people who had watched it in real time, those who had lost sleep through the long nights of synchronization and silence, knew better. They had felt something larger than any one measurement, something that left the air charged and the world faintly reordered. No object remained in orbit, no coordinates pointed to anything solid, yet every machine still hummed in perfect rhythm, every atomic clock ticked with unexplainable accuracy, and every deep space antenna, when left unattended, still heard the same quiet harmony woven through the static. The echo of a system that refused to end. Somewhere between memory and magnetism, between data and sky, the event had found permanence. 3i Atlas had not fallen or fled, it had transformed. What had once been a moving light in the heavens was now a frequency folded into the planet itself, invisible but continuous. Observers stopped calling it an anomaly. They began to call it the quiet sky, because that was what remained. A calm too precise to be ordinary, a silence that carried structure, a rhythm that felt, if only faintly, alive.